Okay, also a warm welcome from me in Würzburg. I am working at the chair of Hakan and am a PhD student and the project manager of the WAMEX3 MarsSymphony project. And I will now introduce you to the WAMEX consortium, WAMEX3 MarsSymphony, what is the project as a whole, then the SkyChem component of the project, the phenomena that we expect in the Martian atmosphere because it's a Mars project, SkyChem 7 as we call it, and then the road to Mars. So what is the WAMEX consortium? WAMEX means Valles Marineris Explorer. So the Valles Marineris is a region on Mars where we expect water could potentially be liquid or occur in liquid form under the right conditions. It's a consortium of many German universities and companies funded by DLR based on a decree by the German Bundestag. So with the project, sub-project WAMEX3 MarsSymphony, we are part of this, and we are one of the first, Hakan mentioned it already, or the first, to our knowledge, German project that has a UAP component officially that is funded by a government. We also have a little video here of one of the non-UAP components, as I call it for today, of a little crawling rover that is supposed to explore caves on Mars. So the overview, as I mentioned already, we have a SkyChem that is our UAP detection component. And we have a gateway in the satellite mockup that does basically communication, but that is very complicated in a way. So it seems like to just be a communication backbone, but a very big component that we do together with a company called IQ Wireless. They have big experience in SDR-based satellite transmitters, and we're building a Ka-band transmission system with them. And we have the blades. That is the picture on the right. That's basically a big maple seed with which we want to spread sensor networks. So I see it clips the image. We want to spread sensor networks on Mars. So the idea is from a re-entry vehicle, you're at high altitude and you want to spread the network. Why would you want to do that? Well, currently we only have assets on the surface at one spot, and then we can measure. But if we can spread out our sensors, that's interesting for weather measurements. That might also be interesting for UAP measurements if we have infrasound microphones and such. The Scout rovers are, for us, basically built by DLR. So we just buy them, let's say it like that. And they are crawling robots to specifically explore caves on Mars. Why caves? In the Valles Marineris, we expect there to be caves. And in there might be life, because if we expect water to be liquid, that's one condition. But we also kind of want to look where we are already in caves, especially lava tubes. That will be the case. That's where we expect it to be the case. So you need an asset to go into such caves, because with a big rover, if you imagine Perseverance or maybe Opportunity and Spirit, you would not be able to go in there. So this rover is specially built for that. Here we also have an overview image of that. So we have a ground station with a Mars orbiter, and we have a gateway component. On the gateway, the SkyChem is mounted. Here we have basically from left to right a UAP, an image that represents a UAP, but also clouds and meteors, because everything in the Martian atmosphere is interesting. We have hardly any man-made objects that interfere. We have the odd rotation system flying along ground, and we have the cave rover communicating all via the gateway. For a moment, I want to look at the project goals. I've presented all of them here, but the red one is really the one we are going to talk about today. So one of the goals that is most interesting for today is we want to build a two-part SkyChem system. So one 360 cam, also known as a SkyChem, typically all SkyChem, and a tracking system. For the autonomous detection of short-term atmospheric phenomena. Okay. I guess the HDMI. Okay, I'm going to continue. And there we specifically mentioned UAPs. Throughout the whole proposal, UAPs are specifically mentioned. They are not hidden in any way, shape, or form, and they are funded, which is quite significant in our perception. Yeah. So SkyCam. We have some experience with SkyCams, and it's basically our eye in the sky. You might have seen this before from videos from us from other talks. Maybe Hakan mentioned it. We've already built a number of SkyCam systems. Here we have a detection from the SkyCam 5, which is mounted in a building just 2 buildings away from here. A bird flock flying over it. So basically, we want to detect and track transient phenomena, lightning, meteors, cloud storms. I will get into those specifically what we expect on Mars later. But the conceptual overview, what do we plan to do with the SkyCam? Why do we bother bringing it? What's the idea? So the all SkyCam is basically our detector. It finds an event, whatever it may be. The tracker then goes to that azimuth and elevation and tracks the object and gives us high resolution data. This will then be processed, and the event will be reported to the satellite and then to the ground station and eventually be downloaded. But what do we expect to see? I mean, with UAPs, it's always the issue. It's the U in UAP tells us we don't know. But there's quite some activity in the Martian atmosphere that we expect and also want to track beyond UAPs. So weather phenomena are a thing. Clouds, there have been images of the clouds. So all of these images are from NASA. The above images are from the Curiosity rover and below from an orbiter. It's a quite high dust level that we see there. Dust storms, of course, are also a thing with the possibility of lightnings. Lightning on Mars are quite controversial. We don't know if they exist or not, but that's where the science begins. That's the interesting part. And we would like to image them. Aurora, something that has only occurred recently with one of the images, and you can see the image quality. The camera was not built for that. You can see the noise in the image. I believe it was done with Perseverance, with one of the mast cams. They took an image of the night sky, and on the left you can see it faintly green glowing. That is what they expect, where they expect to be aurora, and what they conclude to be an aurora. So they attribute to that with the sky cam. Good question. Since we work with you, expected it to be a moon. I'll get back to you on that tomorrow. Right, meteors frequently on Mars. That's was measured by inside seismology. So with seismometers and infrasound measurements, they concluded, okay, yes, there are meteors. They are hard to locate like that, of course, and there are known to us hardly any or no direct observations in the sky. So being able to track these, look at these, of course, adds to the scientific ground. And there might be some man-made objects, right? Landings and re-entries beyond, of course, helicopters, but there is only one right now and it's broken, so we don't expect helicopters right now to be on Mars. We can collect valuable data. And for heat shields, for instance, depending on the spectra we have on our cameras, we can look at the glow of the heat shield and also the landing trajectories. Whoever has worked with landings knows that landing trajectories are huge, sometimes in the length of hundreds of kilometers. Whatever can contribute to lower these is something that helps. And again, we have to deal with those, because if we detect those as a UAP, it's a wrong detection. So that's something that occasionally might occur. To accommodate all of that, and of course, the unknown, we built the SkyCam 7 as our steps towards Mars. Right now, this image was taken yesterday or on Monday. The mobility, this is the SkyCam 7 prepared to be placed outside soon. And in 2 slides, I get to the point where we are going to place it. Mobility was one of our key factors, so it became more compact in the design. Also already kind of preparing for Mars, because we can't bring huge assets, because every kilogram costs in space, even if we have a Starship. Multi-camera system is one of our first multi-camera systems for better all-sky imaging. We can mount up to 6 cameras in this all-sky configuration. And of course, the potential to include a tracker. It's important to say potential because we don't force to include a tracker. So the all-sky can work on its own as well. So it's our mobile all-in-one. It's comparatively small. We are using embedded image analysis with the NVIDIA Jetson platform. Yeah, it's also built to withstand nature. So it's a waterproof casing. We have heaters in there to keep us warm. And you will soon understand why that is especially important. And access and control is via the internet. So basically all cables we need is power and internet. Everything else is happening inside the box. And through a field test, I'm going to show you what some of the detections were. Quite simple, nothing out of the ordinary, but for me, I love this detection because it shows on the right the bandwidth we have. So of course, what do we see? We see a aircraft flying on probably 10 kilometers above the ground. We see a drone that was one of our drones dropping the blades for one of the tests. And in 2 frames, it's hard to see. This is why I put it on the right. We have an insect flying through the screen. So this is especially interesting because with one camera system, we can detect objects within centimeters, within meters, and also within kilometers to quite satisfying resolution, and also with very high frame rates in an embedded small system. So that already is a good step towards Mars. And to test for extreme environments, we do long-term testing. And for this, we place the Skycam 7 on the highest mountain in Germany, that is the Zugspitze. And the Zugspitze has a nice science station on which this system will be placed, of course, outside. It's not, oh, we want to test extreme environment and then we put it inside somewhere. This just provides the power and the internet and the infrastructure to mount it. We have very low temperatures up there. The coldest measurements were around minus 35 degrees Celsius. The highest are only about plus 20, so there's no upper bound testing here. And very strong winds. The highest ever measured were above 300 kilometers per hour. So very, very strong winds. Also, which also is interesting, it has good observation conditions because we are high above parts of the atmosphere. We are about somewhere between 2,500 and 3,000 meters, if I'm not wrong. And that also helps with being closer to the UAPs, to the potential detections, and gives us a clearer view. On the tracker, we are currently, we have the plan to detect an event with the all Skycam, as mentioned before, forward in a way the azimuth and elevation information to the tracker. And then, of course, the tracker goes to exactly that azimuth and elevation and tracks the object, takes images and video with higher resolution. So we don't, for instance, for an aircraft in the image before, you barely make out the aircraft itself. It's a small dot. But with this, you would be able to see the wings, maybe see the registration, even really depending on the resolution. The current status is that we are working with this demonstrator that you're seeing in the image. That's a classically pan-tilt zoom camera. And the goal is to collect higher quality data when we finally have built our own tracker, which we are working on in the next months. Of course, we're building this for a Martian project, so we need to make it space-proof. We need to work towards having it possible of having it operate on Mars. So what does this road consist of? We have long-term observations to make. The Schneeferner house is the first start, but we need to have more of those. What we want to have is multiple Skycams for triangulation. That's also a goal for it to have on Mars, because otherwise, I think the problem was introduced earlier also today. We don't know exactly where it is, which we also don't know how big it is. And with a second observation station, you could add this information. mobile sky cams on the rovers. So we don't only want to have a stationary one. Our gateway currently is stationary. We want to have mobile sky cams that is going with the swarm that WAMEX offers. We also want to have a broader sensor spectrum. So right now we only have visible light cameras. We want to have cameras in higher spectra. We also want to have non-optical sensors like microphones, like radiation sensors, magnetometers, you name it. So we need to look into, okay, what do we expect on Mars and what would be sensible to bring? And of course, very important, can build a great system if it's not space-proof, we're not going anywhere. So we need to adapt our systems for use on Mars, the radiation environment, the travel through space, the temperature requirements and everything. That is one of the key things that we will do with WAMEX 4 and of course afterwards as well. With that, I want to conclude with an image of the whole team. So it's a multi-people effort. Also, the team consists of machinery that is all in the image. Yeah, and I think we have plenty of time for questions.
Thank you. Can you explain how do you approach the question of, I see this glass dome on top of the cameras. When it gets dirty, what happens on Mars?
It's an issue everywhere. There are systems that, so right now we don't have, in this iteration, we are ignoring this issue for now. But we, of course, for Mars, that's one of the things we need to make a space ready. There are systems that have an airflow over it that already keeps the dust particles away and also keeps it heated, which is quite nice. Keeps it on Earth, you would mainly use it to keep the snow away. For Mars, you could use something like that, but it's an issue we need to work on. Maybe some coating, lotus coating, something like that. It's an issue that you have on Mars with the solar sails. So yeah, we need to work on that.
My car with car glass, they have a very good coating that.
Car glass, yeah. Yeah.
Hello, I have several questions. One question is the NVIDIA Jetson that you want to use. It has a fairly small process node, so I'm curious in how far you know that it's already validated for, or if you intend to validate it for the radiation hardening requirements of the Martian surface.
So this exact Jetson that we're currently using, we have not tested for space, but we have a different Jetson flying on Sonata 2. So we have already went through a process. We know how to test the Jetson for such
space already. Okay.
One is the AGX Orion, and we are flying the Jetson NX normal version. I think not the Orion.
We have it in a low Earth orbit, right? And that is not exactly the radiation profile you would get on the Martian surface. So if you consider testing it in some in situ laboratory environment, I don't know, at GSI in Darmstadt, maybe at a heavy ion collider or something, they could probably create conditions more similar to the Martian surface.
Of course, we need to do Mars-specific tests. That's one of the points we need to do on our road to Mars. But again, it's a very good question. I mean, if you want to bring commercial off-the-shelf hardware, you need to radiation test it. Exactly. But we have done it with the NX. We have seen good results. It's operating right now in space. So we expect the future hardware to also work and not make too big problems. Otherwise, shielding is always an answer.
My other question is on the concept where you have, I would call it like a pan-tilt zoom camera that you want to combine with your all-sky camera. And if you have already made your mind about it, how will you look at the issue, for example, with your azimuth tracking? If you want to use that from the all-sky cam to move the tracking by PTC camera, then you have issues like the parallax, because you don't know the ranging. You don't know the ranging inherently from the camera. And another one is the dead time issue in the control, because there's a time delay between your old Skycam and your PTZ camera. And of course, with a dynamic object, that will cause issues. And this is not necessarily deterministic if you use off-the-shelf hardware with the old Skycam's buffers and such, right? Help your mind on this and what about it?
It's a very good question. So first of all, the azimuth elevation information as we are envisioning it right now is coming from the Skycam initially. Afterwards, the Pentil zoom unit with its camera or the tracker with its camera is looking for it itself. So because this Skycam, maybe the object gets too small for the Skycam to detect, but the Pentil zoom object camera would still be able to do that. So then it's doing it itself, which reduces this delay, but it's still there. And
yeah, right. You have two trackers, or you have to jump back and forth between which is operating the tracker.
What you could also do is, depending on what resolution you really require, if you have enough space for the object to move in the frame and to have your controller lag a bit, you would still image it. So maybe leave padding basically in the image. Of course, with that you lose some resolution, but you gain the confidence that it will be in frame, and then maybe you lose 50 pixels or 100 pixels. But you would still be able to track it, which is more valuable in the end. That is one of the solutions that's possible. In the end, we need to try it out and see how the time delay really is and how deterministic the objects are, which there can be absolutely not. So we need to expect everything, right? So yeah, that's one of the issues we need to work with.
I can make an addition. This is a first initial setup, and we will gain experience. We will make tests, and then we will improve the system step by step. So there's a long way to go. We know that. We are aware of that. With the next phase of the project, WAMX 4, we think we get one step further. And then there are several other steps, of course. Okay, so one more question.
It's just a comment, which is that another useful application of a camera that looks at the sky on Mars is to measure the atmospheric opacity by looking at the sun. So you can measure the optical thickness, and that would be nice as well. And for anyone who's interested in conducting a sort of a pilot study looking for UAP on Mars, there are some very low frame rate, very short videos of the sky acquired by some of the rovers, which had filter wheels that would rotate in front of the camera. And so you have a few frames captured over a few minutes, I suppose. But that would be an interesting data set in which to run your detector, perhaps.
Interesting, but can we find this data?
So you can find it on the PDS nodes at NASA. I might be able to help you find them, yeah.